So what you want to do here is you look at a equals -3. A is the number in front of the x squared. B is the number in front of the x. And C is the number in front or by itself the constant. Okay. To find the vertex when it's in this form, what you're going to do is do the opposite of B over 2A, and then you plug it in. Okay. So you want to start with that, and that's why I label those to start. The opposite of B, B is 24, so you do -24 divided by 2 times A. That's -24 over -6, which would be +4. That is my x value of the vertex, okay? That's my x value of the vertex, so now I want to take that and plug it in to figure out what my y is. So I do -3 times 4 squared plus 24 times 4 minus 43. I'm glad they got us some big numbers to work with here. -48 plus 96 minus 43. That should be +5. +48 minus, yeah. Okay. So my vertex is 4, 5. Okay, so I go put that on the graph. 4, 5 would be right here. And now I need to find 2 points to the left and 2 points to the right. The easiest way to do that is to make a chart. My vertex, put it in the middle. 2 points to the left. You can pick anything you want. I'll just pick the 2 directly to the left of that. So I'm going to do 3 and 2. Okay, plug in just 2 numbers less than 4. So to plug in x equals 2, I get y equals -3 times 2 squared plus 24 times 2 minus 43. So that's -12 plus 48 minus 43 would be -7. That's really low. That's right, though, right? Okay. Oh, that's -2. That's why. Okay, I put that's -2. That's why. Okay, I didn't want 3 to be that low. All right, so that's -7 when I plugged in a 2. When I plug in a 3, y equals -3 times 3 squared plus 24 times 3 minus 43. That would be -27 plus 72 minus 43. What's that? +2? 60, 70, looks good to me. So now I go plot these points, 3, 2, and 2, -7. Okay? Once you have one side of it, it is symmetrical, okay? It's symmetrical, so what that means is if I go from this point, and when I go 1 left, I go 3 down, so I go 1 right and 3 down, okay? Over here, it's going to be symmetrical right here. So they're going to match up. They're going to be symmetrical across that blue. The way you think about this, too, is you put a 5 and a 6 right here. It's going to be the same numbers on the y. So that does create the symmetry and makes it very easy to solve. You really only got to solve one side, and then it's symmetric across the other side. This is because, so this is how you solve this problem. Let me talk about a couple more things. That's because this right here is called the axis of symmetry. So again, you don't have to know this for this problem, but just kind of talk about everything in this section since I'm reviewing from last week. That is always equal to the x value of my vertex, okay? So this right here, the x value is my axis of symmetry, and everything's going to fold across that line if you fold it vertically, okay? The y value of my vertex tells you whether it's a minimum or a maximum. You got 2 different scenarios there. If it opens up, remember if the front number is positive, so if it's greater than 0, you get a minimum. And then if the front number is negative, it opens down, so you get a maximum. So here we have a max. I guess I can write what they say. They say at 4, the max is 5. So the x tells you the location and the y tells you what it actually is. So they say at 4 is 5. So again, we know it opens down. Should have said that from the beginning, but it opens down because you get a equals -3. Since that's negative, it opens down, so you're going to have a maximum. We got our axis of symmetry. Trying to think of other things we talked about. We talked about finding the intercepts, which I'm not going to do that on this one because we'll get decimals. But well, I'll tell you this real quick. This number right here would be your y-intercept, because to find the y-intercept, you make x be 0. And if I make those be 0, that's the only thing I have left. So it'd be, my y-intercept would be 0, negative 43. To find the y-intercept, you make x be 0. To find the x-intercept, you make y be 0. Okay? So that's a pretty good refresher over most of the topics on the quadratic graph section. That one is due Sunday. But what I want to jump to today is the stuff that's due next week, since I don't see y'all really too much before we get in there. Let's try seeing what they had in here. So solving systems of equations. There are a couple different ways to do it. One of the ways we can do it that we don't really talk about in this class is graphing it. What you are looking for when you solve a system of equations, like on this one, you have two different equations. What you're actually looking for is the intersection of these two equations. So there's 3 scenarios that you get. When you do this, you can have 2 lines that intersect, okay? The intersection point is the answer. That is the one point that is on both of these lines. So we could graph this and find it, just look at it, right? But it's really hard to graph it by hand because it's hard. We don't draw it perfectly. We don't space everything out perfectly. If we graph this on a computer, it'd be super easy to do. So we're looking for that intersection point, the one point that satisfies both of these equations. They also, if it's parallel, you would have no solution because they never intersect. The definition of parallel is that they never intersect. And then the weird one is if I have a line like this, one on top of the other, like 2 lines on top of each other, they actually are the same line. So you have, I think they say all real numbers, all reals or something like that. I don't think we'll run into that too much because this is an intermediate algebra topic a little bit. So we don't go, so you can graph these to solve the answer because you're just looking for the intersection, but we're just going to go over the algebra ways of doing it. So substitution is one of the ways to do that. What you're going to do on this one is substitution is easier when you have a variable already by itself. So since we have y equals this right here, I can take this and plug it into my y in the other equation. Since I know y equals 3x plus 17, I can just rewrite the other equation. Let me rewrite it down here so I have some more room, or over here. Rewrite the other equation, and instead of writing y, write what y equals. Now I have an equation with all x's in it, and it makes it pretty easy to solve. I can distribute the 5 and get 15x plus, what's that, 85? And then combine my x's, so that's 13x. Then subtract 85 from both sides, so that's negative 65. Divide by 13 is negative 5, okay? So that is my x value that's correct. Once you get one answer in these, you just take it and plug it in, okay? You can plug it into either equation, this one or this one. It doesn't matter which one. On substitution, it's always easier to plug it into the one that's already solved for. So if I plug in a negative 5 for this x, I get 2. So these intersect at the point negative 5, 2. Okay. That, are we fixing to say something?
A question. So you know how at the top, this is how it says use substitution to solve the system?
Yeah.
When we take our test here in a couple weeks, does Alex ask you that before the thing, or does it give you the problem?
It might say it, but it doesn't matter. You can do it either way you want to.
Okay.
Yeah. There's no way for them to judge how you do it on this one. There are some specific scenarios where they make you do it a certain way, but when we do the review, I don't think any of those are going to be like that on the test. On the test, I try to pick the problems that are open-ended so you can do it any way you want to. So even if it says substitution, you don't have to use substitution.
Well, refresh your
What?
memory.
What'd you say?
Refreshes your memory.
It refreshes your memory, right? I am all about only teaching one way to do stuff. I don't want multiple ways to do stuff because I don't want to confuse you. But in this scenario, it is actually easier to use substitution since it's already solved for y. Okay, I'm all about doing it the easiest way. So since it's already y equals, it is easier to use substitution. The other way to do it is called elimination or addition. What you want to do here is add these up so that a variable cancels out. If I were to just add these up right now, it would be negative 8x plus 13y equals 4, right? So that doesn't help me at all. But what I can do is manipulate these so that when I add them up, something cancels out. I didn't pick a very easy one to start with here, but let's cancel out our x's. So the number that I can get to cancel out our x's is if I made the top one be 15x and the bottom one be negative 15x, right? 3 and 5 would be easy to get to 15. But I need one to be positive, one to be negative, so that when I add them up, I get 0. So if I need the top to be positive 15x, I'm going to multiply this by negative 5. Okay? So negative 5 times negative 3x would be positive 15x. Negative 5 times 4y would be negative 20y. And negative 5 times negative 2 would be positive 10. Okay. Make sure you multiply everything in there by negative 5, because if you don't multiply everything in there, you're changing the equation. So we want to make sure we multiply everything. And then on the bottom one, to get that to be negative 15x, I need to multiply by 3. So 3 times negative 5x would be negative 15x. 3 times 9y would be 27y. 3 times 6 would be 18. Okay? So now when I go to add these up, 15 plus negative 15 cancels out. Negative 20 plus 27 would be 7. 10 plus 18 would be 28. And now I have a super easy equation to solve. Divide by 7 and y equals 4. Okay. So you can manipulate these so that when you add them up, a variable cancels out, and then you're left with something super easy to solve it. How many of y'all have seen this before? Yeah, a few of you? Okay. All right, and then just like before, once you get the one answer, you just plug it in to find the other answer. So I'm going to plug it into the bottom one. It doesn't matter which one you plug it into. So I get negative 5x plus 36 equals 6. Subtract 36, and I get negative 5x equals negative 30. Divide by negative 5, and x equals 6. So these two intersect at the point 64. I will say on Alex does a good job on these to not give you fractions. So if you're ever working a problem and you get a crazy fraction or decimal or something like that, you probably just missed a minus or a negative somewhere, so go back and check your work. It should just give you a nice and easy integer like that. Yeah, we can solve this. That's fine. All right, so what happens when we have something like a quadratic in a linear? For a quadratic in a linear, you have, just think about this for 2 seconds. You're going to have a parabola and then a line. So you may get two answers of where they intersect, okay? So multiple answers are possible on this one. Again, you could graph it and get the answer. But algebraically, what you want to do on this one, you have to use substitution because you can't really add them up with an x squared and an x and a y. But we know y equals this and y equals this, right? So if by like transitive property, if this equals y and y equals this, then you know that those two things have to be equal. So you can actually set these equal, the top one equal to the bottom one, because you know they both equal y, so they have to equal the same thing. Okay, it's substitution is what you're doing. You're taking this and plugging it into the y. But if the transitive property makes more sense to you, where you are setting both equal to each other because they equal y, that's fine. All right, so you got an x squared and an x. Anytime you have an x squared and an x, you got to think factoring. So I want to set it equal to 0 by adding 2x and subtracting 18 from both sides. So I get x squared minus 6x minus 16. There's nothing left on this side, so I write 0. And then you go through your factoring steps. You check for a greatest common factor. We are looking at here what multiplies to be negative 16 and adds up to be negative 6. That'd be negative 8 and positive 2. So x times x is x squared. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So that looks good. Set them both equal to 0 and solve those. So I get x equals 8 and x equals negative 2. Now previously, once we got one answer, we had to plug it in to find the other answer. So now I have to plug both in because just like in my picture over there, I'm going to have 2 points of intersection. So if I plug in x equals 8, I'd plug it into the bottom one because that'd be easier, right? Negative 2 times 8 plus 18. You could plug it into the top one if you wanted to. That'd be y equals 2. And if I plug in a negative 2, that's y equals negative 2 times negative 2 plus 18. That would be y equals 22. So these intersect at the point 8, 2 and negative 2, 22. Okay. So just like before, once you get an answer, plug it in. But on here, you get two answers, so you got to plug both of them in. And you got two intersection points. All right, the other one has to do with graphing inequalities. I'll start with a different one. Yeah. Graphing an inequality is just like graphing a line, except there are two differences. Okay. All right, so this is like y equals mx plus b, even though you have a greater than symbol. So you still go through the same steps. My m is going to be negative 1 because there's like a negative 1 in front of the x. So that means I would go like negative 1 over 1. That would be down 1 to the right 1. And then my y-intercept is 5, so that's my starting point. So we start at 5. And then we do what our slope says. It goes down 1 to the right 1, okay? And we have our graph. Now the two differences. If it is less than or greater than, if it doesn't have equal to, that means it's not going to be equal to any point on the line, so you do a dashed line, okay? You do a dashed line. If it's less than or equal to or greater than or equal to, you do a solid line, okay? And I'll talk more about this once I get the picture. And the second part is you have to shade. And I'll talk about why once I get the picture up here. Okay. So this is a greater than symbol, so it is going to be a dashed line. So I am just going to dash my line. It's not very straight, but that's fine. You do that by just clicking this button on Alex. So you have a dashed line. Let me graph or do the shade part, and then I'll talk about the why we do this. So to shade, this is less or greater than. So basically, I'm taking every answer that is greater than this line. Now, a lot of times when it's in y equals mx plus b, you can look at it and tell that this is the greater than side, right? The greater than should be above. But algebraically, if it gets tough, sometimes when the line starts to look like, like this, it's kind of hard to tell which one's the greater than or less than side. So what you can do is you can plug in a point that's not on the line. And the easiest one to always plug in is 0, 0. So if I plug in 0, 0, 0 is greater than negative 0 plus 5. Is 0 greater than 5? That is false, right? So what that means is that any point on this side of the line, if I plugged it into here, it would come up false. So what this means is I need to shade, since I got false, I actually need to shade on the other side of the line. If I plugged in any point on this side of the line, it would be true, okay? So I could take this point right here, 8, 6, and if I plugged it into here, it would be true, okay? The reason we do dashed on the line is, what happened? Did I bump it? If I do dashed on the line, that means the points that are actually on this line are not going to hold true, okay? If I plugged in the point, oh my goodness, plugged in a point 1, 4 into here, well, let's do it real quick. 1 is greater than negative 4 plus 5, so that negative 4 plus 5 would be 1. It would be 1 is equal to 1, or 1 is greater than 1. That's not true. That is why we dash this line, because any point that I plug in this line would not be true on this. If it was greater than or equal to, we do a solid line because it would show that it's true. So when you're solving an inequality, you're actually going through and showing that any point in that shaded region would work in that equation. Okay, so anything greater than that would work. All right. So just like with the system of equations, you can do systems of these. The system of these, I'll do the 3 one because it's really not that much harder than the 2 one. But when we did systems of equations just a second ago, we were looking for the intersection of the 2 lines to figure out, because that's the one answer that would work for both lines. On this one, we actually got to look at the intersection of the shading, okay? This line right here, when you have x equals a number, anybody remember what kind of line it is when it's x equal a number? What'd you say? It is a vertical line, okay? If you forget that, just go to x is less than or equal to 4. And what it's saying is x is always less than or equal to 4, so it doesn't really make sense to draw it this way. Hopefully you recognize that it is either horizontal or vertical. So it only makes sense to draw it up and down. This would be a solid line, right? Okay. So this would be a solid line, and I'm looking at everything less than or equal to 4. What I would do is, if I were you, is I would just put a little mark on your paper or right to the left of that line, so that I know that I'm going to shade to the left of that line, okay? Like, say left of the line on your paper just to remind yourself, okay? This one, when I have y equals a number, it is horizontal. Again, if you forget, just go to y is 5. It doesn't really make sense to do it this way because then they would all be that way. So this is saying it doesn't matter what x is, y is always less than 5. This is just less than, it doesn't have an equal to, so I'm going to do a dashed. Happy there. Okay, and I want less than, so again I'm going to shade to the below. So if I were going to shade this answer right now, I have to be to the left of the red line and less than the black or blue line. So my answer would be in this area right here, okay, to be the left and below. But we got one more to do. This one, what we want to do is put into y equals mx plus b so we can read it faster or do it. So I'm going to subtract, whoops. I'm going to subtract 4x, and then I divide by 5 to get y completely by itself. So I had divide everything by 5, so negative 4/5 x plus 2. My slope is negative 4 over 5, so I go down 4 to the right 5, and then my y-intercept is 2. Okay. Be careful if you ever divide by a negative. Remember, if you divide by a negative with greater than or less than, what do you got to do? You got to flip the sign, okay? All right, so let's graph this one. I'm going to 2. Wait, let's go ahead and write this so we don't forget 2. We want a dash line, right? And then I go down 4 to the right 5, and I'm going to do a dash line. Okay. We're greater than that, so I'm guessing that we're going to shade above it, but remember, we can always plug in a point to check it. I'm going to use green. I know it might be a little hard to see, but so if I plug in 0, 0, I get 0. Actually, it's easier to plug it into this original one. 4 times 0 plus 5 times 0 is greater than 10. Is 0 greater than 10? No. So I'm going to shade away from 0, 0. It's not this side. If I plugged in anything on that side of the black line, it wouldn't work. So I need to shade on this side. So I need to be above that black line, below the blue line, to the left of the red line. A lot of times it is going to make a triangle when you do these problems. Okay. So this would be like a real life example of this would be if I was manufacturing 2 products, I could only manufacture up to 4 of this product and up to 5 of this product because of the time constraints. Okay. In this case, I don't know what this line would be off the top of my head. I'm making something up. This would be like, I don't know, how much people can work. I don't know. So like these are the options. Like I can manufacture the X product 3 times and the Y product 2 times, or I can manufacture the X product 2 times and the Y 4 times, and I meet my time constraints. So like this, that's kind of where this is used in real life. It's called linear programming. All right, I believe that gives you a quick little overview of all the different stuff that they do in those sections.